Alright, test 3-4 Exponents is on Thursday, March 7th. So it'll be test 3-7-19. Also want to remind you my website, bit.ly/Cumberledge, which hopefully if you're watching this video you've been there. Okay, let's get started. So first thing I want to talk about is anything with one exponent or anything with one variable or no variable can be done in the calculator or checked in the calculator. So I'm going to circle the ones that can be checked in the calculator, checked in the calculator, checked in the calculator, checked. Technically this one could be checked in the calculator. And this one can be checked in the calculator. So those 1, 2, 3, 4, 5, 6 can be checked in the calculator. Now I'm going to put a star on the ones that can be done in the calculator. So anyone without a variable, done in the calculator. These have no letters. That's why they can be done in the calculator. I don't know what kind of star that is, but we'll go with it. I believe that is it. Technically this can be checked in the calculator as well. Okay, so ones with circles means it can be checked in the calculator. Ones with stars means it can be done in the calculator. So let's go ahead and get started. So this is multiplying. Remember, with coefficients we treat them like normal. 3 times 4 is 12, but with exponents, a to the 5th times a to the 8th, remember, exponents is how many times you multiply something. So we multiplied it 5 times and we multiplied it 8 more times. So 8 plus 5 is 13. So remember, you add exponents. So I'm going to show you how to check this in the calculator. So 3, I can only use x to the 5th power times 4x to the 8th power should equal 12x to the 13th power. So if I go to my table, everything should match, and it does. Therefore, my answer is correct. Okay. So number 2 is multiplying as well. M to the 7th times m to the negative 2nd. Well, multiplying just means add the exponent. So 7 plus negative 2 is m to the 5th power. So let's check it in the calculator. X to the 7th power. Ooh, I don't know what I'm doing. X to the 7th power. X to the negative 2nd power. And we're saying the answer is x to the 5th power. Everything matches, so there is my answer. Now here we're adding. Anytime you see adding, you are not messing with the exponents. You leave them alone. You're just adding. So if I have x to the 4th plus x to the 4th, well, if I give you an x to the 4th and I give you another x to the 4th, you have 2 x to the 4th powers. Okay, so let's double check that. X to the 4th plus x to the 4th should equal 2x to the 4th. And that works, therefore that is my answer. Now anything to the 0 power is 1. So a to the 0 plus b to the 0 plus 3, c to the 0. So a to the 0 is 1 plus b to the 0 is 1 plus 3 times c to the 0, so 3 times 1. Well, 3 times 1 is 1. 1 plus 1 plus 3. So 1 plus 1 is 2 plus 3 is 5. So really you can kind of just, let's see if this works. X to the 0 plus, I'm going to just use the same variable. No, it doesn't work. Okay. Never mind, you cannot do this one in the calculator. Or this one. My fault. I thought maybe it would work. Anything to the 0 power is 1, therefore this whole thing is to the 0 power, therefore the whole thing equals 1. Okay.
Alright, Eagles, that was a 2:55 bell. After this time, you need to be in the classroom with a teacher, sponsor, or coach, or you need to be outside waiting for your ride. After this time, you need a phone to, or no, not a phone, you need a pass to be in the hallways. Thank you, and we'll see you tomorrow.
Sorry about that. Okay, so x squared plus x squared is just like number 3. If I give you an x squared and I give you another x squared, you have 2x squared. So again, you could check this one in the calculator if you wanted. Now let's look at number 7. Okay, so I'm going to start on my home screen. 27 divide negative 3. So I know right away that I'm going to have a negative 9. I'm going to go ahead and keep my decimal, or my fraction line. Now, I have a to the 4, a to the 4, those are the same, therefore they cancel. I have more b's on top, so 6 minus 3, remember when you're dividing you subtract. 6 minus 3 is 3, and I have more c's on top, so 9 minus 2 is 7. There's my answer. Here, remember, anytime you have a negative fraction, negative exponent, it means it's on the wrong side of the fraction, so we're going to move it to the bottom. Now, remember, that's positive, so we're leaving it on the bottom. So we have d to the 8th power, and I brought down c to the 4th. Now, can the top be empty? No. So remember, anytime the top is empty, you put a 1. Here we're going to move this down, b to the positive 6. That cancels, so I have c to the 5 over b6, b3, c2. I know I'm totally not saying that right, but you know what I mean. Okay, now remember, when you're multiplying, like right here, you add the exponents, and when you're dividing, like here, you subtract. So 5 minus 2 is 3, so c to the 3rd power, then 6 plus 3 is 9. Okay, now look at number 10. Alpha y equals, enter 2 over 16. So that simplifies to 1/8. Now, I'm going to move this down to the bottom. So I'm going to have an x to the positive 7 down here. I'm going to move this to the top and have a z to the positive 4. So I have 1y squared z to the positive 4. And then I have x to the positive 7, y 3, because I moved that and I moved that. Now, I want you to realize we can combine these by multiplying and these by multiplying, and those will be combined by dividing. So, I'm going to keep my 1/8. 3 minus 2 is 1, so I'm going to have my y1 on the bottom. 1 plus 7 is 8, and then 1 plus 4, because that's 1, is 5. So there's my answer. Now, the 1 you won't see if it's multiple choice. So it's z5, 8, x to the 8th power y. Okay, number 11 can be done in the calculator. Alpha y equals entered as a fraction. Dang it. So my answer would be 5 over 7. Now this one will not be done in the calculator. Now I want you to realize this whole top thing is to the negative power. And even this y to the 3. So the x does not have a negative power, so that's staying. So I'm going to switch those. So I have y to the 3 on top, y to the 3rd power. I have this x that was already there, and then I have x to the negative 3, y to the 4. I can forget about that 1 because I brought it to the bottom, and now it's positive 1, and that doesn't change anything. But I still need to move this up. So now I have y3 x to the 3rd, y to the 3rd power, x to the 3rd power over xy to the 4th power. So I want you to realize there's more x's on top and more y's on bottom. 3 minus 1 is 2. 4 minus 3 is 1. There's your answer. 13 can be done in the calculator. So the answer is 81. 14 can be done in the calculator. $15 can be done in the calculator. So this one doesn't work out pretty. So it's not really, I always tell y'all, you can't type an ugly decimal and it doesn't turn into a fraction. So we really have to think about what this one means. So remember, the top is your cowboy. He goes in the house as the exponent, and the bottom is your root. Okay, so the bottom is your root and the top is your exponent. Okay, so exponent root. Okay, so negative 81 to the third power. So we're doing a cube root of negative 5314441. And if you do math, so clear, I'm going to do 4 math 5, which tapes a cube root, or a not cube root, to the fourth power for fourth root, negative 5314441. It doesn't work. It's a non-real answer. Okay, we're just going to go ahead and leave the answer like that. Okay. I want you to realize that you could take the negative out and do 4 math 5, 531441. So it's actually, just kidding, don't leave it like that. I'm glad I kept going. If I take the negative out, I have I, so then I can do the square root of the positive, and so my answer here is 27I. Okay. 16. Is 1 over 25. One ninth. (36 over 25). I know that's a really weird 6. Sorry about that. Okay, now let's look at number 19. Remember, this is just like number 1 where you're multiplying. Okay, so 2 times 4 is 8, and then you add the exponent. So 5 plus 3 is 8. So 8b to the 8th power. And then the last one, and remember, this one can be checked in your calculator. So this is another one that we need to do by hand, like number 15. So, to the 1/2 power, I want you to remember that means to the square root. This one should work. Why is that not working? So, square root of 125 over 9. Oh, that's why. So, this because the top isn't pretty. So, I want you to realize that you can do the square root of 125 over 3, because the square root of 9 is 3. And then we could do the tree. I know it's been a while. 5 and 25, and then 5 times 5 is that. Remember, that's a pair, so we can take it out. 5 square root 5. That's the leftover, so it goes back in the house, over 3 is your answer. So 15 and 20 are kind of hard, but you could have totally figured out the ugly fraction answer and then looked at your multiple choice answers and typed those in and seen which 2 ugly decimals match. Okay? Let's look at 21. So remember, the top is your exponent, your cowboy, and the bottom is your horse, your root. So this is a square root of c to the 17th power. So again, just like number 21, exponent, root, so cube root of m to the first power, which is just m. Now here, remember, your root is the bottom of your fraction and the exponent is the top. So there's exponent form. And remember, when there's nothing here, it's always 2. So this would be w over 2. K to the w over 2 power. So this says circle the expressions that are equal to x to the 7 over 8. Remember, this is your exponent. And this is your root. So that's at 8 as your root and 7 as your exponent. This has 7 as your root and 8 to your exponent, which is wrong. This is 8 to your root and 7 as your exponent. This is 7 as your root, which is wrong. I want you to realize 1/7 means 7 is your root, which is wrong. Now 1/8 means 8th is your root and 7 is your exponent, which is right. This is saying 8 is your exponent, which is wrong. 7 is your exponent. 1/8 means that's your root, therefore that is correct. Remember, when it's on the bottom of a fraction, that's your root. So this is saying the 8th root. This is saying the 8th root. Okay, so look at 26. It says circle the expressions that are equal to. Guys, this is a calculator problem. So 729 to the 2/3 power is 81. So this equals 81. So we can check these. Square root 729 to the 3rd power does not equal that. So that is not your answer. Okay, here. So math 4, 729. Oop, I forgot to put it in parentheses. To the 2nd power is 81, so that is 3 to the 4th is 81. 9 to the 2nd power is 81, therefore all three of those are equal. Which of the following has a greater value than 3? Again, calculator problem. 2 to the -2 power is 0.25. 16 to the 1/2 power is 4. 4 to the 3/2 power is 8. And 32 to the 1/5 power is 2. So it says circle the value. They're greater than 3. This is greater than 3, and this is greater than 3. Now it says list in order from largest to smallest. So let's do that. So this equals 27. 3 to the -3. 0.037. I like to leave them as decimals because decimals are easier to see when you're talking about largest to greatest. Okay, so we're looking for largest would be 27. Okay, next would be 9. Next would be 5. 3. And then last but not least would be 3 to the -3 because that was a 0.037. Okay. Now let's look at the bottom. It says match the exponent rule with its equivalent. So remember, when the bases are the same, you add. Oh wait, just kidding. This is adding. Okay. When the bases are the same, the exponent should be the same when you're adding or subtracting. These are not the same, therefore they cannot be simplified. When you're multiplying and the bases are the same, you add the exponent. So m plus n would be a g. Okay, x to the -m power would be 1 over x to the m. Remember, that's when it means it's on the wrong side. So that would be h. Here, these are not the same, but the powers are the same. So this could be a xy to the power of m. Okay. Because remember, when you have power to a power rule, you give it to everything on the inside. So we did. Okay, 1 over x to the m would be... Oh, that's... Sorry, x to the 1 over m. Sorry. Remember, that's your root. The bottom is always your root. So this would be m root, which would be c. Again, this cannot be simplified because remember, the bases have to be the same and the exponents. Remember, power to a power rule, you multiply, so it would be m times n, which is d. And then last but not least, you subtract when you're dividing and the bases are the same. So that's f. Alright, let's look at the back. It said graph the parent exponential function. Remember, that's just y equals 2 to the x power, and I'm just gonna sketch it. Actually, we'll actually graph it. So 2 to the x power. So negative 2 is 0.25, a half, and then 0, 1, 1, 2, 2, 4, 3, 8. So it looks like this. Okay. It says the graph of the exponential function h is shown on the grid below. For what value of x is h of x equal to 6? So remember, h of x just means y. So y is 6. Remember, y is your height. So where is it a height of 6? Right here, which is at x equals 1. Remember, you're given y, so you're finding x. Okay, label the following as increasing, decreasing, or neither. So let's do that. So I'm going to just type these in here. I'm going to look at them in the table. Do you see how this is every other one is negative, positive, negative, positive? So this is neither. Look at B. So you can either hit graph or go to your table. So this is obviously decreasing. You can even look here, see how the numbers are getting smaller. So this is decreasing. 4 to the x minus 3. So if you notice, these numbers are getting bigger. So this is increasing. Negative 4 to the x minus 2. So every other one is positive, negative, positive, negative. So this is neither. These numbers are getting bigger. So this is increasing. Every other, so this is neither. Every other one's negative and every other one is positive. So I want you to realize these are getting smaller, so this is decreasing. And last but not least, these are getting smaller, so it's decreasing. One thing I do want you to take notice to is all the ones that are neither have a negative inside of the parentheses with an exponent. All the ones that say decreasing have a fraction inside the parentheses with an exponent. Okay? Just something to think about. Okay, number 40. What type of transformation was used to obtain the graph h of x equals 2 to the x minus 4 from the graph of h of x is 2? So remember, up here is an inside change. So if you have minus 4 as an inside change, that's I had. Remember, I had is opposite, so minus 4 would be this way. So that means we went right 4. So let's double check that. So horizontal shift right. Guys, double check it. You're given a calculator. 2 to the x minus 4. 2 to the x. So if you look, there's the x minus 4. And there's the 2 to the x. See how it went to the right? Everything shifted to the right. So what type of transformation was used to obtain this graph from that? So from here to here, it went right. Okay. 41. Which of the following is true about the following function? Let's type it in our calculator. So let's hit graph. We do see that it's decreasing. We see that it goes down to negative 2. We know that because of this. So my asymptote Do you remember that this number is always your asymptote? Okay, so the graph is decreasing. We just saw that, yes. The y-intercept is 0, -1. Let's look. So at 0, is it 0, -1? Yes, so that is true. The graph has a horizontal asymptote of y equals -2. Yes. And so my answer is D, all of the above. Okay. How does the domain and range change from this function to this function? So let's look. 1.5 parentheses 2 to the x power, and 1.5 parentheses 2 to the x plus 2. So I want you to realize, I'm just going to hit graph. So here's the first one, and then here's the second one. I want you to realize that it really just shifted to the left too. Domain wise though, they're both gonna keep going left to right for this ever. So domain, if I could spell domain, domain stayed the same. Range also stayed the same. Do you see it still goes down close to 0 and it goes up forever? So there was no change to the domain or the range. Okay, now it says if 2x to the 4 equals 2y plus 2, which of the following statements must be true? Well, remember, the 2's cancel, and you get x plus 4 equals y plus 2. So if you notice, these are all in standard form. So I'm going to subtract y from both sides, and I get x minus y plus 4 equals 2, so minus 4 on both sides. I get x minus y equals 2 minus 4 is -2. So the x minus y is -2. So now let's solve these last 6. So remember, this is where the yellow card comes into play. All of you should have one of these on your desk. So looking here, can we turn 27 into a 9? So if you look at 9s, it's 81 or 729. So we can't turn that. But we can turn both of these into a 3. 3 squared is 9. 3 cubed is 27. So 3 squared to the x plus 5 equals 3 cubed to the x minus 1. The 3's cancel. I'm going to go ahead and distribute. 2 times x is 2x. 2 times 5 is 10. 3 times x is 3x. 3 times -1 is -3. Remember, you're setting the exponents equal to each other. I just kind of threw in the step of distributing so I had enough room. So I'm going to subtract 2x from both sides. And that gives me 10 equals x minus 3. So I'm going to add 3 to both sides. And I get x equals 13. And remember, you can check these in your calculator. 9 to the 13 plus 5, because that's what's there, should equal 27 to the 13 minus 1. Are those the same ugly fractions? Yes, they are. Therefore, this is correct. Okay, now let's look at 45. So I have 25 and I have 125. So if you look, 25, 125. 5 is going to be their base numbers. So 125 is 5 to the 3rd power. Okay, and then here I can get 1 over 5 squared to the x power. But to get rid of the fraction, I have to make it negative. So I have 5 to the 3rd power equals 5 to the -2 times x. Bases cancel, and I get 3 equals -2x. Divide by -2, divide by -2. And I get x equals 3 over 2. -3 over 2. Or 3 over -2, either way. Here, I want you to realize that 36 is 6 squared, so I only have to change one base. So 2x equals x plus 1 minus x minus x. 2x minus x is x, so x equals 1. Okay, remember, you could be checking all of these in the calculator. I'm just trying to save time for me after school. Okay, look at number 47. 3 is prime, so I can't make that base change. But 9 is 3 squared. So I have 3x equals 3 squared to the 4th. Okay, which gives me 3x equals 2 times 4, which is 8. The bases cancel, and I get x equals 8. So just a reminder that you can check this. 3 to the 8th power should equal 9 to the 4th power. Those are equal, therefore we are correct. Here, we're going to have to turn both of these into bases of 2. Okay, so 2 to the 3rd power equals 8. 2 squared. And don't forget what was already there. Bases cancel, and I get 3 equals, I'm going to go ahead and distribute. 2 times 2x is 4x. 2 times negative 5 is negative 10. So I'm going to add 10 to both sides. And I get 4x equals 13. Divide by 4, divide by 4. So x equals 13 over 4. Again, we can check this. So this is 8. So we're going to do 4 to the 2 times 13 over 4 minus 5. And that equals 8. Therefore, we are correct. Last but not least, okay, 125. 5 is prime, so we can't mess with that. But 125 is 5 cubed. So 5 to the x equals 5 cubed. Don't forget to multiply that time what was already there. Bases cancel, and I get x equals 3x times 12, or plus 12, sorry. So minus 3x minus 3x. So I get negative 2x equals 12. Divide by negative 2, divide by negative 2, x equals negative 6. And again, we could check it. So 5 to the negative 6 power gives me this. 125 to the negative 6 plus 4 also gives me that. So that is correct. All right. Test is Thursday, the 7th. Good luck. If you have any questions, you can shoot me a remind, or hopefully I'll be back in class after jury duty tomorrow. Have a great day.